Hello geometry students, this is Mrs. Hefty here. We are on section 2-6, which is on algebraic proofs. Before you began this lesson, you were asked to take a bunch of postulates and definitions and match them with the descriptions that you were given on the next page. I'm going to go through those briefly and you can check and see if you have those correct. So in our first one, we were given C in the interior of angle XYZ. So if I take a minute and I draw X, Y, and Z, and I put C in the interior, it helps me see what the conclusion is here then. The measure of XYC, so XYC plus CYZ will equal the whole entire angle. This is called the angle addition postulate. Remember how I did 20 degrees plus 30 degrees equals 50 degrees in chapter 1? And that's what we're talking about here. We need to know that so that when we're applying those to proofs, so again, that was called the angle addition postulate. In your second one, from the left side to the right side, A is being distributed to AB plus AC. And so you remember that one hopefully from algebra. That's the distributive property. In our third one, if A equals B and B equals C, then A equals C. Here I have A, then I have the B here equals the B, and here's the B again, and the C. That's called transitive. And transportation is moving around. Transitive is also where things are being moved around. In our next example, we have AB equals BD, then AB congruent to BD. So what you're doing is you're looking at what you're given, and you're looking at what the conclusion is, the then. What happens from the given to the then? You see how the equal sign is changing to a congruent symbol? That's the definition of congruent. Remember, congruent means equals. Let's take a look at our next one. If angle B is a right angle, then the measure of angle B equals 90. If I have a right angle, then what lets me say it's 90 degrees? You're right. That's the definition of a right angle. Right angle means 90-degree angle. Are you getting the pattern of this? Look at the if. What happens to the if to the then? What's changed from the yellow to the green? Do you see that they're adding C? That's the addition property. In our next one, if A equals B, then A may be replaced by B in any equation or expression. Being replaced. When you're in a sport and you're coming out and somebody is taking your spot, what's happening there? You're right, it is a substitution property. Let's take a look at our next example. If A equals B. Okay, so what's happening from the if to the then? Those are supposed to be time signs. A times C and B times C. So what happens from the if to the then? Correct. C is being multiplied, so that would be your multiplication property. All right, let's take a look at the next one. A equals A. Nothing has changed here. That is called the reflexive property. Let's take a look at our next one. If A equals B, then, okay, what happens from the if to the then? You see how it's being divided by C? That's called the division property. In our next one, it reads, given angle A and angle B are supplementary, then the measure of A plus B equals 180. What lets you say, if you have supplementary, what lets you say that they add to 180? Definition of supplementary. You're given D is the midpoint of MN. So I'm going to draw that. Here's my M. There's my N. And D is the midpoint. What does that mean, people? What does that mean when D is the midpoint of MN? Some of you say, oh, it's right in the middle. You're right about that. Some of you will say, well, they're the same amount. Yeah, they're the same amount. So you mark those two with the same hash mark. That means that they are equal. And so this is the definition of midpoint. In our next one, if A equals B, okay, now what happens here from the if to the then? Do you see what the difference is? The subtractions of the C's. So that's subtraction property. All right, our next one says if A equals B, then, it should be the word then, should be then B equals A. Now, kids get these confused. Sometimes they think it's the symmetric property or the reflexive property, and they don't know which one is which. Do you see how they're being switched around? A and B are being switched around here. I call that the switching property, or the symmetric property is how I remember it. Let's look at our next one. Given angle A and angle B are complementary, then the measure of A plus the measure of B equals 90. If something is complementary, what lets you say that it adds to 90 then, that both of them add to 90? Yep, you're right. Definition of complementary. On our next one, I had a correction there. Do you see that at the end there, the AB should be AC? Given line AC with B between. So I'm just going to put it anywhere. It looks like it's in the middle, but I don't know that for sure. Then I can take line segment A, add it to line AB, and add it to BC, and then I get the whole thing, which is AC. We've talked about that in chapter 1. When you add two pieces of segment together and get the whole entire segment, that's called the segment addition postulate. ST is perpendicular to TR. So this is ST and this is TR. Then you have a right angle. That would be definition of perpendicular. All right, now in this section it says state the property and justify each statement. So what you're looking at is you're looking at the if, and then you're looking at the then. And what's changing from the if to the then? Do you see how those two are being switched around? That's the symmetric property. I'll get a huge eraser there. In number 2, if measure of angle 1 is 90 and measure of 2 and measure of 1 are equal, then measure of 2 is 90. So what they've done here, guys, is they've taken 1, and now instead of 1 is the same thing as 2, so they've put 2 in its place. That is called the substitution property. In number 3, you have AB equals RS, and then RS, see how that is WY. Then AB equals WY. This is the transitive property where they're moving around here. Here's AB to RS, there's RS to WY, so now WY and AB are going to be together. That's called the transitive property. In number 4, what happens from your if to your then? Okay, so you see that you're really multiplying by a half, so I take the multiplication property, or if you're saying, hey, you're dividing by 2, I'd also take the division property. In number 5, you've got the measure of 1 plus the measure of 2 is 110, and 2 is equal to 3. So do you see here then? Here's 1, and there's 1. And then instead of 2, they're putting 3 in its place here because 2 and 3 are the same thing. So when you are putting it in the place of something, that is called a substitution property. In number 6, RS equals RS. They are matching. That is called reflexive property. In number 7, AB equals RS and TU equals WY. Now, you might see this better if it was written this way. Okay, do you guys see here that these two together are being added here? See how that's being done? And these two together are being added and written there. That's called the addition property as well. It's called the addition property as well. Just like I did this, if I went 4 equals 4 and 5 equals 5, I'm going to add them together. I'm going to get 9 equals 9. Do you see how that works, people? So that's really what's happening here in number 7. In number 8, you've got measure of 1 equaling measure of 2, and then you've got 2 equaling 3, and then 1 equals 3. Again, you've got 1, and then these 2's are together, and then 1 and 3 are equal. That is the transitive property. The next thing we're going to look at is we're going to look at some algebra proofs, and you guys did algebra last year and you wrote down all of your steps. You are showing Mr. Ludlam or your algebra teacher your steps to prove how you arrived at your answer, and that's basically what we're going to do here. So you're given 4x plus 6 all divided by 2, and that equals 9. I want you to prove x equals 3. Well, the first thing you would do is you would write down what you were given, and how did you know that you had that? You would say, well, my algebra teacher gave that to me. So that would be given. The next thing you would decide is you would want to get rid of the 2 on the bottom, and so what you're going to do is multiply by 2 on each side. So that's the multiplication property. From there, the 2's cancel, and you would have 4x plus 6, and 2 times 9 is 18. The 2 and the 9 are being multiplied, and 18 is taking its place. So that would be a substitution. From C to D, do you see that you're moving that 6? So you're writing a minus 6 and a minus 6 on both sides. So that's called the subtraction property. Then from D to E, you would take 6 minus 6, and that'd be 0, and 18 minus 6, and that would be 12, and that would be a substitution property. Instead of 18 minus 6, you're putting 12 in its spot. Then you need to get the x alone, so you're dividing by 4. So you're going to write 12 divided by 4. That would be your division property. And then in algebra, you would cancel these 4's, and x would equal 3. Let's take a look at our last problem here. Again, you're given this equation, 4x plus 8 equals x plus 2, and you have to prove x equals negative 2. So same thing, if you were showing your steps in algebra, the first thing you would do is write it down, and you would say to your teacher, the reason why I wrote it down is because you gave it to me. That's the given. Then you would want to get your like terms together, so you would be moving your x. So you would write a minus x and a minus x on both sides. So 4x plus 8 minus x, and then x plus 2 minus x. And you are subtracting that x, so that would be the subtraction property. Then at that point you would be combining your x's together here to get 3x, and an x and a minus x would be 0, leaving with 2. That would be a substitution. Now you need to get your numbers together on the same side, so you would write 3x plus 8, and then you would minus the 8, and then 2 minus 8. That would be subtraction. Then you would get your simplify. That would be 0, so you would write 3x equals, oops, So you would write 3x equals negative 6. 2 minus 8 is negative 6.